talk about infrastructure maintenance here. We're actually, I think, more talking about maintenance, but kind of like management and observation and seeing what's going on the network. But the bullets here, the objectives are configure SNMP. SNMP is a protocol, and here we have to have a manager, a something, and I've got one running here on a virtual machine. I'll bring over here in just in a second. Troubleshoot network connectivity issues using ICMP echo-based SLA service level agreement, where we get guaranteed a certain amount of bandwidth, certain amount of service from an ISP. Troubleshoot problems using local span. Span is switch port analyzer, sometimes called port mirroring, where we watch one port on another, because if you remember from a switch, a port only sees the traffic to it and the broadcast traffic once the MAC address is in the MAC address table. And then troubleshoot basic layer 3 end-to-end connectivity issues. But we looked at this, I think, a little bit the other night. Let me see if I can get this in here. This is a piece of software that you can get called PRTG, and it is a commercial software. Makes it a little easier to do things. But when we talk about using the protocols, it'd be nice if I could make him go away. When we talk about using the protocols, we have to have something to use it with. We have to have something to use it with, and this is one of those applications that we can do. And it got for me a list of some of the workstations, some of the stations on my little home network. But we have a Probe Health here. I've got a red up here. I've got a new alarm. Let's see what it is. Probe Health. It says it's down. Messaging interval delay. I'd have to go back and see, but we do get messaging on these things. And go back to devices, I hope. And it lists some things, and when we looked at it, and again, a DNS 127.0.0.1, that's on this particular machine, and the CPU load that's on this machine, we can look at it, what's going on with it at this time. We should also be able to, I'm not going to find it, do a rescan so that we get the actual immediate of what's going on. But back to this one, let's go down here to the machine that I'm on. It had, and I guess it's gone away. There it is, CPU. The CPU load on this machine, it shows at 99%, it actually is pretty high. We should be able to go in here and refresh and see if it's changed any. Still pretty high because it's rendering that video and it's running this virtual machine and all that other stuff. But to give an idea of what SNMP can do, we need to get something that reads the protocol. SNMP is a protocol. It's not something that we can go in and say, okay, SNMP at the command line, here we go. And when we're going to configure it, we're going to look at the different versions of what goes on with it. So this is showing me the CPU load. And I can look here real quick and see. And it is pretty much correct. It's running 99% right now on this. So PRTG, there are a number of them available. I want to get rid of this. And then I want to close this application, maybe help my CPU load a little bit. If I still have it here. Today, a list of ones that are available. PRTG comes up pretty high, and then what is available on each of those softwares. And that's what we're really talking about, is a monitoring software for these things. Logic Monitor, Network Performance Monitor. This is, how can I think of the company? Anyhow, they're free. It'll come to me. I guess we could just go there. Maybe. Anyhow, different ones that are available. So SNMP Manager, something that can go out here and read the information from the devices. The device themselves are going to have what are called OIDs, which are numbers that represent the different parts of the machines that we are monitoring. So SNMP requests go out to port 161. They're going to go out from what's called an ephemeral port or a temporary port on our device. It's not going to be 161 to 161. The ports that we talk about in these things are the ports that are running at the destination. They represent a service. So this represents port 161. So we send an SNMP request and it comes back in an SNMP response. And this says 161. 161 is going to be the source port in this case. And it'll go back to the temporary port or the ephemeral port that was applied to it. So it's going to be slow here for a minute. Okay, we'll try these things. Network management service, say we have a routing problem, can't reach the device. This can't reach the device, access control list, firewall rules, different things may be stopping it. Access control list, you need to be sure that you're not, if you're going to use SNMP, that you're not blocking port 161. This is a network management system says that we have a routing problem, up or down. Response doesn't come back. SNMP can queue the device and it may give us an answer back. And in this case, it says that fast Ethernet 00 is down. So that would explain our routing problem. It will keep a history of what goes on. When I was at the university, we would monitor the bandwidth on all of the rooms so that we would try to find out who's the bandwidth hog, who's trying to download a movie, who's doing whatever, so that we could be sure that we had bandwidth, sufficient bandwidth available to all of us. The performance monitoring, the different things that we can use, ICMP ping, availability, latency, and response timers, and you can look at it, what is the response time, what is the latency, we can do that. Is the device up as long as it's responding to pings? So we can use it for availability. SNMP used everywhere else, and it can query all of the different things, the interface traffic, the interface status, CPU, disk storage. WMI is the Windows management instrumentation, which we may use on Windows machines. Similar process. You can set them up to run either on a machine or off of a machine so that we can get the information. So in SNMP we have the manager, and then the manager queries the agents. The agents are running on the devices, and when we say agent, that is something that means that it's got to be SNMP capable. I set this up, I had to enable SNMP on my Windows machine in order for it to send it, tell it I have a 99% utilization. So SNMP capable, the SNMP agent, SNMP capable device. Not all are. The home router is probably not going to be SNMP capable. I would love to monitor what goes on, the bandwidth utilization on my home router. Can't do it. SNMP manager, that's where we have the software running. The software here that we talked about, and that was like the PRTGs, MRTGs, and other manufacturers of these things. Application layer control, that application layer protocol provides capability to collect information from the network devices, and it can map and buffer or store those so that we can create graphs of what's going on. And that's useful because you know what your utilization is at maybe different times of the day. You come in one morning and then at 0200, 2 o'clock in the morning, you find out that you have 100% bandwidth outbound. That's kind of an odd situation. So then you investigate further and find out that somebody left the FTP port open, and a user in Germany discovered that and stored a movie there and was sharing that information to share out his movie. He was using your bandwidth, using your storage. So the graphs, things that give us visual indications as to what's going on with the devices. Include management systems called the managers and agent software. Agent software, SNMP capable. SNMP managers are hosts called a network management system, on which the SNMP management applications is installed. Is a SNMP agent's a piece of software installed on the network device that maintains a database called the management information base, the MIB, and those are usually terms that you probably want to recall, with configuration information, status, and counters on the device. So we have the devices, and we have the management software that allows us to see those. SNMP uses get and set messages to communicate between the management system and the agents. The get message is used by the agent to query from an agent. So we get a get next, get bulk, a get, and then the get response for these things. The set message is to modify the variables stored on the MIB. So the set message would be for management of it. And the get message is for information that we can then chart to see what's going on. The get next, get bulk are different forms of the get message. Include pairs of requests and response messages between the management system and the agent. And here we get, and once we ask for the get, we get the response, and then that is the pair. The get request and the get response are paired up. Store information, perform statistical analysis and different network parameters, and things that you probably have thought about. What are you going to do? CPU utilization, disk utilization. Disk utilization is a big one because, as you know, on a Windows machine, if it runs out of disk space, it just quits working because it needs it needs to be able to use disk capability to do a number of things. SNMP notifications we may have with them. Trying to get this thing synced. Messages sent by the agents to establish communication with the to notify the current state of communication with the NMS, the current state of the MIB variables. The MIB is the management interface base. The variables, these represent the devices or the sensors, I guess would be a better word for that. Interface gig 001, interface fast Ethernet 0, whatever. All of the different ports may be on your switch, or you might just want to watch the outgoing port, look at the network traffic that goes on it. So the agent notifies the NMS when an event requires attention as an encounter, a switch is down, like I got those warning messages on mine. So I got a message, an inform, router interface is down, and it acknowledged the inform. I got a message that I had a problem. It showed up in a nice red, and then I could go check what's going on with the notify. Two types of notifications are a trap notification message, which is based on a fire and forget process, and then an inform message, which includes an acknowledgement. And here it shows the inform message has an acknowledge that goes with it. A trap message, you never know if it actually got there or not. An inform message, you do. And again, whatever is configured is what is going to be used for these things. This is the structure of a MIB. So what we have, the structure of the MIB starting with a 1.3.6.1.4.1.9 and the Cisco in this thing. So we have the 1.3.6.1, the internet, .4 is private, .1 is enterprise, .9 gets down to a Cisco, and then we can keep going, a Cisco whatever, maybe a Cisco NIC, a Cisco interface. They all have, in each of the devices, the sensors are going to have a number associated with it. Database maintained by the SNMP agent in the network device. The agent set the values in the MIB variables. The values are used by the management system to monitor and control the device. Variables are defined as object IDs, and then the hierarchy forms a tree that is shown there in the picture. If you did a Wireshark, and this is a Wireshark scan, I said OID, OID I think is what they are. This shows SNMP get request and an SNMP response. SNMP response here. We have these numbers, and these numbers represent different devices that are responding to the SNMP get message or get request message. So we get a get request, which is not shown, and then a get response, which the information down here, get response, request ID, the variable bindings that come back from the device. So those numbers represent the data that we're going to chart on our devices. SNMP versions, we have really 1, 2, and 3. Version 1, version 2, and version 3. Two important features supported by SNMP packet filtering. Support the use of IPv4 and IPv6 access control lists to filter incoming packets. To distinguish SNMP messages from other messages are configured to ensure that the agents respond to get messages from the hosts only. So we can set up a filter for SNMP that only allows a specific IP from the NMS host, and that's going to be from an IP address, which is going to mean the source IP address. We can either use a simple or an extended, a standard or an extended access control list. Security versions 1 and 2. They use a password. They use a community string, and there are 2 community strings. You can change it, but the defaults are public for read-only and private for read-write. And these are clear text. If you can see the traffic in a Wireshark, you can read the community string. And again, public and private are the defaults. We can change those if we want to. Host an SNMP agent is configured with a community string that acts as a password. I guess we'll call it a password because you can change it. The problem is it is not encrypted in 1 and 2. And that's the big difference with 3. 3 gives us encryption. 3 enhanced security features not available in these other 2. And then the read-only community can use to forget messages, cannot send set messages, and the default is public. And the read-write can be used both get and set, and its default is private for the community string. Get set messages only the community string that matches the community string configured at the agent. Yes, been through that. Our headquarters activity decided to change the community string for us one time, and all of our SNMP monitoring went down. So what we did was plugged in a hub. We weren't clever enough to use a switch port analyzer, which we'll talk about in a little bit, but we plugged in a hub, watched for about 2 seconds, got the community string, put it into our management system, and then we're back up with monitoring, watching what was going on the network. So version 2, enhancements over version 1. Version 1 was kind of a crisis or a short-term fix in these things. The original 2 does not include communities. SNMP version 2 was upgraded to include them, and this is SNMP 2C. We usually just call it SNMP version 2. Original definition without communities no longer in use. Supports additional data types, enhanced protocol operations, specifying the read-only and the read-write community strings, access control list settings for filtering packets. It allows bulk retrieval, huge volumes of data, table retrievals, minimize the number of messages between those if we do a bulk retrieval. Error reporting, error codes for these things. Version 1 supports one type of error codes, and version 2 multiple error codes. Exception reporting, different types of exceptions, such as no instance exceptions, no such object exceptions, and end of MIB view exceptions. So you get a message back, you try to add something and it's not there, then we're going to get the exception messages that we know why it didn't get added. Version 3 is the new version. Includes all the features of 1 and 2. Replaces the community-based password with other advanced security features. It has message integrity, has undergone any modifications, which is hashing, so that we know that what we sent or what was sent is what we got. It uses encryption to secures the messages and an authentication, usernames and passwords, and not the community string. So it is a much more secure, but it's not something that, okay, we installed it and it does that. We have 3 different levels that can be installed. No auth, no authentication. We get message integrity. So we're always going to get that authentication, message integrity and authentication, and then private message integrity, authentication, and encryption to prove the privacy, authentication, and no auth. No auth is going to be the default of these things. So if we want security, we have to make the changes to get there. Configuration of these things: SNMP server, community, the community string, whether we're going to have a read-only, access control list name, or whatever's going to go in here. Enable the agent with a read-write. Same thing, community string, read-write, IPv6 ACL name or ACL name on these things. ACL, we're going to filter who can actually use the get condition. You don't have to put an access control list on it. You can if you want to limit who can actually see the traffic. V3 does not include the community command because it uses usernames and passwords and not community strings when we do that. It uses SNMP server group and SNMP user commands to specify, and the server group is going to be for radius or attack acts when we do those things. The next topic is service level agreements, IP service level agreements, and it's a contract between a service provider, either internal or external, and we can have internal SLAs as well as external LSAs. External, where we go with whoever is going to provide it. Spectrum is mine, and they do businesses, so they would do service level agreements. They didn't do one with us, obviously, with the individual, because that would really be too hard. But defines the level of service expected from the service provider, output based, in that their purpose is specifically to define what the customer will receive. So they are contractual agreements that specify service level, and usually we're concerned about bandwidth, we're concerned about response time, delay, ICMP traffic, voice traffic, UDP, voice probe. These are the different things that we can use. ICMP traffic in these things, a UTP VoIP probe. What we have is a SLA source, a service level agreement source, us, that's going to send a probe, a voice over IP probe to the responder, and the responder is going to be maybe at the ISP or at a remote location, so that we can check what kind of VoIP response we're getting through the cloud, through our provider. Multiple customers, service level agreements. The service provider is actually delivering a quality of service that you're paying for. How do we know? We know because we're going to trust but verify, right? You guys probably don't remember him. Trust but verify what's going on. We're going to trust that they're giving it to us, but we're going to verify it with probes, with the service level agreement, IP service level agreement. We can do pings to see what kind we get here. And this one is a VoIP probe. We have to have a responder at the other end. If we just use a ping, it's not such a big deal. As long as the pings get answered, we can see what the delay, how long it took to get there and back. IP LSA service level agreement is available in Cisco routers, used to monitor network performance and troubleshoot. SLA, again, is the contract. SLA enables measurement of a variety of parameters used to verify whether the device meets the terms or not. Instead of measuring the traffic, generate traffic that is similar to end user traffic. And these are a little more complex than the CCNA. CCNA is actually the IP SLA, ICMP IP SLA. IP operation that generates test packets to measure the performance is called a probe. And if we have a probe like this, we have to have a responder at the other end. And that means that maybe the ISP would have to provide the responder for us. Send test packets that resemble normal traffic, receive responses, and then they measure the QoS parameters that come back. Involves two things, the IP SLA source and the responder. The responder is at the other end of the area that we want to test, to confirm. Echo operation, pretty straightforward, which is ping. But operation that does not require a responder, because we're going to bet on the fact that somewhere down here we're going to get a response, and this is a source, and it goes down to echo request, and then the destination host gives us a response. And you probably have done this occasionally. You do a ping and see what kind of response time that you get. What's the round trip time? Use the echo request message. The ping generates the echo request. A host receives it and is capable of sending it. A dedicated router is not required. We don't have to have the responder in this case, because we're using something that's available on practically all of our devices. Commonly used to measure the end-to-end response time between the host and the router. Time to travel. The transmission of the echo request and the receipt of the reply shows the response time when we do these things. So the basic IP SLA is send an echo request, wait for the reply, and measure the round trip delay. We're going to look and see what the delay is in these things. So a pretty basic, straightforward way to do a little test there. The configuration steps. Enter the SLA configuration mode, IP SLA. Specify the echo operation. And the reason they're going through the configuration is we can schedule it. We can run it at different times of the day. We can have different numbers of echo requests that go out. So specify the operation mode by using the command SNMP echo, the destination address, destination host name, source IP, source interface that we're coming from. Specify the number of seconds at which the probe is to repeat. How frequently do we want them to go out? Operational parameters. Some operational parameters, pattern history buckets kept, history buckets kept, history filter, history hours of statistics, kept history statistics, distribution interval threshold. We can also tell it when to start. You don't have to run it all the time. You can run it at certain times of the day, so it can be scheduled. Necessary, schedule it with the IPSLA schedule command so that you are getting the information at the times that you think that you need the information. Echo-based collects the network data, can be used to identify and troubleshoot issues. The show IPSLA summary command, a number of commands that are down here, displays the information about an echo operation, the IP address, destination, ICMP. Show IPSLA statistics allows us to do the statistical counters, displays the counters, the number of successes and failures of these things. The summary and the chart at the bottom there displays the summary of the SLA operation, detail history, debug, trace. The debug command again tells us exactly what's going on the device. So the next topic here is called a local span. Span is switch port analyzer. And let me get try to get my packet tracer. Here, and I have a span demo. You know, we can talk about it after you see what it actually does. It's a pretty straightforward thing. Span switch port analyzer. So when I have this thing, I have two devices here, and then I have a sniffer sitting out here. So if I look at the configuration on this device, show run, down here at the bottom I have monitor session, and that's the command to set it up, and we have to number the session. Monitor session source interface, fast Ethernet 01. This is where the information is going to come from. Monitor session 1, destination interface, fast Ethernet 024. And it is, so we're going to do monitor session and then a number 3 or 4 here. And then we can do source and then a port number, a VLAN. We can monitor a VLAN and interface. We can do remotes, but they don't really talk about remote. What we're talking about is monitoring a port on this device. Remote span, we can remotely, and we use VLANs there also, the span source or destination VLAN for those things. If we did remotely, what we would do, we'd have a source port, we'd send it to a VLAN, the VLAN would send the information to us, then we'd have a source VLAN and send it to a destination port, if that makes any sense. So we have the ability to do these things, and just a little simple, hopefully look at this thing and it doesn't crash. So it's ping 192.168.1.2. And when I go to my sniffer here, which is the GUI, we have the ICMP traffic that went across. So we can monitor a port. We could monitor all of the traffic going out. We could, the uplink port, if we wanted to, we could send that traffic, so we see all the traffic going off of the switch. If you do that, be careful that you don't overload the destination port from the source port. In other words, you probably wouldn't want to make the source port a gigabit port, which is very busy, and then the destination port a fast Ethernet port, because it wouldn't be able to handle all of the traffic. So the words here for this thing is that it's a mechanism used in Cisco to make copies of Ethernet frames and send those copies to another tool, such as a switch analyzer. It sends it to another port, and then we can put a sniffer on the other port. And if you do that, you can put a computer on there and not give it an IP address, because it's still going to get that information. We're not sending anything to the IP address. So you can run a sniffer there without an IP address, and not going to get the broadcast and all the other stuff. You're not going to generate any traffic with it. Span copies frames from one or more ports called the source ports into another port called the destination port. Network analyzer attached to the destination port receives the frames for analysis. A local span is a type of span in which the source and destinations are present in the same switch. A set of rules defined on that switch specifies the source ports, and we just did that with the monitor sessions to be monitored in the local span. So monitored sessions is the command that's used, the configuration command that's used to do these things. Let's see, source port on the local span is also called a monitor port, because the traffic flowing to that port's analyzed in the local span session, and all ports in the switch except the destination port can be used as source ports for the span session. The local span session, the direction of the traffic is monitored, is also configured, can be ingress, egress, or bidirectional. So we can monitor the traffic going into the port, out of the port, or both. And probably both. Bidirectional is the thing that we're going to use. And when we do those, receive, RX, TX, or both, it's going to be the keywords that you use in the configuration. Other types of sources, CPUs, ether channels, source VLANs, can all be monitored with these things, with the switch port analyzer. CPU, source CPU, and its CPUs are monitored for troubleshooting issues, analyzing CPU traffic. The device is not performing to the level that we think it should, and we think it may be a CPU issue, then we can do that monitor session. Local TX keyword. The commands are down here. Source CPU, single instance, interface list, whatever we need to monitor with this thing. CPU. I guess I turned it the wrong direction. Monitor sessions. Okay, the CPUs are monitored for troubleshooting, route processors, a monitor session command with a local TX keyword we got there. The source command with the CPU keyword is used to specify the source CPUs of those things. Ether channels, we've talked about and configured ether channels. This is one that probably want to be careful because ether channel can carry a lot of traffic. Network traffic flowing through an ether channel can be monitored by configuring it as the source in a local span session. And here, local span session needs to be monitored. The ether channel group is configured to act as the source port. A single local span session can analyze the traffic in one or more ether channels. Key points, which includes a port that serves as a destination port in one local span session, cannot be configured as a local span source in another local span session. That goes around the world, I think. So an ether channel, which includes a port that serves as a destination port in one local span session, cannot be configured as a local span source. In other words, if you're a destination, you can't be a source. A local span session with an ether channel group as its source monitors the entire ether channel group, and you would expect that if we use the group nomenclature. And up here we said that traffic in one or more ether channels, that we use the ether channel as the source. When an ether channel group is monitored, the direction of the monitored traffic is applicable to all physical ports. So again, we're going to monitor the ether channel. We're going to monitor all of the physical ports. Can be configured as local span sources along with VLAN trunk ports, and a port is part of an ether channel group, can be monitored individually outside the ether channel. And it's like all the other things. We can configure these individually. The big deal about the ether channel is, yeah, it groups them together and allows us to configure them all simultaneously. We can go in and make changes. We can shut them down individually. We can shut down the entire ether channel or shut down the ports individually. Source VLANs, and when we talk about these guys, we're talking about can act as a source for a span session. When a source VLANs are used, the traffic flowing through the VLANs is monitored in the span session, so we can use the VLAN as the source for these things. And if we had a remote, since we can't send it back to a port, we would have a port would be the source, and we would send it to a VLAN. The VLAN would go across the trunk to us, and then the VLAN here would be the source, and then the individual port that we had our sniffer on would be the destination port of these things. One or more VLANs monitored is called a vSpan session. The source in the vSpan session includes all the source VLAN ports. It can also include ether channels. Points here, vSpan can be used to monitor traffic flowing in both directions of all the active ports in the VLAN. And again, I think here worry about the traffic. How much traffic? If we're monitoring an entire VLAN that's got, I don't know, 20 ports on it, that can become a lot of traffic. What's going to be big enough to handle all that traffic? That's just a consideration that you need to think about. Only Ethernet VLANs are used as source VLANs. Filtering cannot be applied to the source VLANs. vSPAN copies only the traffic from the monitored VLAN to the destination port. Ingress and outgoing traffic of layer 2 VLAN ports is monitored in the vSPAN session. And then monitored session down here is session number, source VLAN, the VLAN ID, and again we can do receive, transmit, or both in these things if we want to get the in and the out of these devices. The destination port, and we're going at these things and we're getting close, but the destination port receives the copies of the Ethernet frames, called the monitoring port, receives copies of the frames from all the source ports as long as it's the destination port. Local span session, the destination port, and the source ports must be present in the same switch in the local span. And we do have remote span. The destination port, the switch does not, for the destination port, the switch does not use the MAC address. And if you didn't think about that, if we use the MAC address, then it would go to the destination, to the source port or to the wherever it was intended to, and not to our monitoring port. So it does not use the MAC address. Ethernet port can be, any Ethernet port can be used as a destination. It can act as a destination port in only one span session. So it can't be a destination port for multiple sessions. It can only be a 1 and a 1. Cannot be configured to work as a source port. So the destination and source have to be separate. Ether channel cannot be set as a destination port in a span session, and then a port acts as a destination, and a vSPAN session cannot be configured as a source port. It's the same thing again and again and again. The source and the destination got to be separate ports. We can't have a source as a destination, and then here the ether channel cannot be set as a destination. Span problem is a pretty straightforward protocol. Frames are not getting captured correctly at the analyzer. Use the show command to check the span settings, identify whether the frames are copied correctly to the destination port. This is the show. Yeah, do we have the correct ports configured on this thing? Congestion at the destination port, limited traffic copied, too many source ports. Avoid the entire VLAN as a source VLAN when only a few ports may be needed to be monitored. And again, we can do the entire VLAN, or we can do individual ports here to do that. We can have multiple ports in a single session as the source ports, and then they'll send them all to the same destination. Show command, output to the show command to verify the span settings. Show monitor sessions all, show monitor session. Show monitor detail are the commands that we would use to see what's going on with our monitored sessions. Layer 3 end-to-end, we just kind of throw things in occasionally, but some of the most common connectivity issues between the host and the default router: incorrect IPv4 settings at the host don't match the DNS settings, LAN interface configuration, subnet mask, subnet ID, default router, which would be the default gateway, or incorrect subnet mask, DHCP relay agent not connecting, DHCP server improperly configured in the wrong VLAN on the wrong port, a number of different things that can happen there. The configuration on the relay agent, if our DHCP server is someplace else, is a good place to start with those. Router interface failure, show commands here, and SNMP, if we have it configured, will tell us that the interface is down. Will give us a nice little red flag there that says that we have an issue. Availability of more than one route for routing packets, overlapping subnets in the network, may calculate multiple routes And then the overlapping can cause poor use of the subnet plans. Overlapping routes may happen. Typically, you're going to get a notification that you have an overlapping route because the routers don't like that. Use of the incorrect addressing and overlapping in BLSM variable link subnet mask. We have set it up wrong in the show IP route command, most commonly used to troubleshoot the layer 3 connectivity issues. That works. Trace route works. Trace route, how far you get, the router that you get to where it fails is typically going to be the one where the issue is. And then the key points here, SNMP and application layer protocol, capability to collect information from network devices. SNMP agent's a piece of software. We can't just say, okay, we're going to use SNMP. Set messages, get messages to get the information, set messages to modify the interfaces. 3 versions, 1, 2, and 3. 3, it has security. 1 and 2, 1 is not used anymore. 2 uses community string as a password. A password mechanism called communities. SNMP 3, message integrity, encryption, authentication, security groups and levels that can be used in these things. And the IPSLA service level agreement available in the routers can be used to monitor network performance, troubleshoot issues. The ICMP echo operations, a type of SLA which does not require an SLA responder because we would expect something at the other end could be set up to respond to us. SPAN, switch port analyzer, makes copies of the frames. It's also called port mirroring. Port mirror, where we see the traffic on one switch port on another one, because as we know, typically we're not going to see traffic except the traffic to us on these things. So that is the maintenance and the management tools that we talk about, SNMP being the big one, but you have to have something that will actually display the get and display the SNMP information for you.